our Science 8 episode. My name is Teacher Hannah, and today we are going to talk about the factors that affect potential energy and kinetic energy. Is this the first time you've heard the terms potential and kinetic energy? I bet you've heard this in your elementary days. So do you still recall the meaning of these words? Let's try to remember these two types of energy in the sports ground. Let's go! So first, let's describe the word energy. What happens when an athlete kicks a soccer ball? When the athlete kicks the soccer ball, he applies a force to the ball, and the ball consequently moves in the same direction as the force applied. So the force applied to the ball changed the state of motion of the ball, from rest to moving. There is something that is transferred to the ball and sets it in motion. That something is called energy. So there is a transfer of energy from the athlete to the ball that causes the ball to move. This transfer of energy is called work. Therefore, we can define energy as the ability to do work, which is when a force is applied to an object and it moves. Energy is everywhere and comes in many forms, and the two most common forms of energy are known as potential energy and kinetic energy. So, what is potential energy? So, potential energy is a form of energy that has the potential to do work, but is not actively doing work or applying any force on any other objects. In simpler terms, it is the stored energy an object possesses at rest or by virtue of its position in a field. How about kinetic energy? In order for an object to move, the stored energy or the potential energy in the object must be used and converted into kinetic energy. Therefore, kinetic energy is the energy that an object possesses due to its motion, or simply the energy of all objects in motion. Now, let's look at what factors affect the potential energy and kinetic energy of an object. Let's start with the potential energy. There are different types of potential energy, but in this lesson, we are going to highlight the gravitational potential energy for objects on Earth. In equation form, the gravitational potential energy is equal to the mass of an object in kilograms times the free fall acceleration due to gravity, which has a constant value of 9.8 meters per second squared, times the height of the object above ground in meters. So based on the equation, we can conclude that the main factors affecting an object's potential energy are its mass and the height at which it is positioned. But how do these two factors affect an object's potential energy? Let me give you an example. Two swimmers are standing on the platform about to dive into the water. Swimmer A is heavier than swimmer B. Who has the greatest amount of potential energy? So swimmer A has a lot more potential energy because he is heavier. Because an object with more mass requires a lot more energy to move it over a distance or set it in motion. As a result, a heavier object has more potential energy that it can use to change its state of motion. How about height? Consider these two swimmers with the same mass but standing on platforms of different heights. Swimmer A is standing on the platform with a lower height. Who has the greatest amount of potential energy? So swimmer B has a lot more potential energy because he is standing on a higher platform. Why? Because the closer an object is to the Earth's center of gravity, or simply the closer the object is to the ground, the less potential energy it has. So when an object is lifted up or moves away from the ground, it gains potential energy because it has a greater potential of falling some distance to the ground. So keep in mind that an object's potential energy is proportional to its mass and height above the ground. Now let's proceed to the factors affecting kinetic energy. Kinetic energy can be computed using this equation. Kinetic energy is equal to 1/2 times the mass of the object in kilograms times velocity squared. So the velocity of the object is measured in meter per second. The equation shows that kinetic energy is affected by the mass of the object and its speed or velocity. These are the two main factors affecting kinetic energy. But how do these two factors affect the kinetic energy of an object? For example, we have two runners who are running at the same speed. Runner A, on the other hand, is significantly heavier than runner B. Who do you think has the most kinetic energy between them? So runner A has more kinetic energy than runner B due to its greater mass. Remember that the greater an object's mass, the greater its kinetic energy. Why? Because similar to potential energy, a more massive object will require more work or energy to move it from rest to velocity or set it in motion. So the lesser the mass of a moving object, the lesser its kinetic energy. What about the two runners with the same mass? Runner A, however, moves more slowly than runner B. Which of them do you believe has the most kinetic energy? So the kinetic energy of runner B is greater than that of runner A. Why? Because simply runner B runs faster than runner A. It shows that the faster a body moves, the more kinetic energy it has. In fact, as the equation shows, kinetic energy is proportional to the square of the object's velocity. So since velocity is squared in the kinetic energy equation, increases in velocity have exponential effects. So doubling an object's mass doubles its kinetic energy, but doubling its velocity quadruples its kinetic energy. So the motion of an object or the kinetic energy it possesses is determined by how fast it's traveling and how much mass it has. Now, let's have an activity time before we finally end this episode. We have two sets of situations. In the first set of situations, you will determine which object has the most potential energy in a given situation. In the second set of situations, you will determine which object has the most kinetic energy. So let's start with our first set of situations. In our first set of situations, determine which object has the most potential energy. Let's start with our situation 1. A 1-liter bottle of water and a 100 ml bottle of water were placed on a shelf. Which object has the most potential energy? So the 1-liter bottle of water has the most potential energy because it is heavier. Let's move on to the next situation. An empty cart on the first floor of a building and another empty cart on the 5th floor of the same building. Which object has the most potential energy? The answer is the empty cart on the 5th floor because it was placed at a higher height. In our second set of situations, determine which object has the most kinetic energy. Let's start with our situation 1. A bowling ball and a tennis ball are both moving at the same speed. Which object has the most kinetic energy? The answer is the bowling ball because it was heavier. Let's move on to the next situation. Two motorcycles of the same mass were moving at different speeds, with motorcycle A moving faster than motorcycle B. Which object has the most kinetic energy? Motorcycle A is the correct answer because it moves much faster than motorcycle B. That concludes this episode. I hope you've gained a better understanding of potential and kinetic energy, as well as the factors that influence these two types of energy. See you in the next episode. Stay safe, and I hope you've learned something new.